Hello everyone, this is lecture 5 part 1 of current electricity. Today we will start with a new topic discussion that is based on EMF, cells, internal resistance, etc. So in the previous lecture we completed with the concept of resistors in series and parallel. How are the equivalent resistance being calculated if the resistors are in series, and similarly we also understood that if the resistors are in parallel, what will be the calculation for the equivalent resistance. So for series it was just summation of everything. So if R equivalent has to be calculated for, let us suppose 3 resistors, then that will be equal to R1 plus R2 plus R3. And similarly if there are 3 resistors in parallel and we need to calculate the equivalent resistance for that, then that will be just using the formulation 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Or in similar terms, for just this simple instance, it will be nothing but R equivalent is equal to R1 R2 R3 upon R1 R2 plus R2 R3 plus R3 R1. So let us start the discussions today. Today new discussion will be dealt with. So let us not waste any time. So I am Sameer Lavankar. Let us begin our discussion. Okay, so just a bit of course outline for you before starting the complete discussion. So first of all, we started with the introduction chapter, introduction concept, in which we understood the difference between the charges being put at rest and charges being put in motion. So we finally understood that if the charges are put in motion, then that constitutes an electric current. The next was electric current, in which we understood the mathematical formulation of electric current, that is small q by t. That is, if we take a virtual area A through which charges are being passed from say left side to right side in time t, let us suppose that charges have a charge q, then the amount of charges which has been passed from left side to right side is equal to q, and per unit time is t. Hence the definition of current is nothing but small q by t. Similarly, in the third point of electric current in conductors, we understood the concept of how the electrons are being either in the free form or in the fixed form. So if they are free for a larger extent, then that constitutes an electric conductor. Then as the amount of freeness keeps on decreasing, the material keeps on changing from conductors to, let us say, semiconductors and finally to insulators. So next thing was Ohm's law. In Ohm's law we understood the brilliant idea of Ohm scientist, that was V is directly proportional to I, and therefore we got a new equivalent proportionality constant, that is V is equal to IR. This R was known to be known as resistance. Similarly, we understood that R is directly proportional to L upon A. Removing this proportionality constant, we got R is equal to rho L by A, where this rho came to be known as resistivity. Okay. Next was the drift of fifth, the concept, that is drift of electrons and the origin of resistivity, in which we understood the concept of capital Vi, small vi, t, tau, and finally using all of them we understood the concept of Vd. This Vd came to be known as drift velocity or drift speed. Then also using the similar concepts and using the previous concepts of the Ohm's law, that is J, conductivity, etc., we originated the formula for conductivity, and we knew that the reciprocal of conductivity is nothing but resistivity. That is how the original resistivity came into picture. The next thing, in the sixth point, we understood the concept of limitations of Ohm's law. In limitations of Ohm's law, we understood 3 different types in which the Ohm's law is not satisfied, that is V is not directly proportional to I. Also we understood 2 things about a diode here, in which if we reverse the direction of voltage, then if the voltage direction is reversed, then the graph of V and I is not similar in the third quadrant as it is in the first quadrant. Similarly, we also understood a different concept called as GaAs, a material that is known as gallium arsenide, which also does not follow Ohm's law. In the seventh concept of resistivity of various materials, we understood that there are basically 2 types of resistors. In this we also understood that there is a method, there is a color coded method which is used to understand the resistance of a resistor with the tolerance provided. in the next concept of temperature dependence or resistivity, we understood how the resistivity of a material changes with temperature and how the resistivity dependence on temperature is different for conductors, and it is different or it is opposite to that of conductors for semiconductors and insulators. Okay. In the next concept of electrical energy and power, we understood the concept of what is power. Power is basically a product of V and I. If we use Ohm's law here, then it is nothing but power is equal to I square R or V square by R. And using similar concept and trying to apply it in examples, we understood that if we need to transfer a large amount of power from, let us say, transmission from the power factory from power factory to our homes, then it has to be supplied through a very high voltage, so that the power leakage is very less or the energy dissipated is very less. If it is possible, but we cannot use that power high voltage supply in our homes, so it has to be gone through a transformer which dissolves or which reduces its voltage from a high supply, from a high voltage to a low voltage as in 230 volts or 440 volts, which can be directly used in our home appliances. Okay. So, this was the ninth concept in which we understood the electrical energy and power. Finally, in the previous lecture we completed with the 10th concept, that is combination of resistors in series and parallel. In this I already explained to you. So, for equivalent series resistors in series, it is nothing but R1 plus R2 plus R3 dot till Rn, and similarly for parallel resistors it is nothing but 1 by Rn is equal to 1 by R1 plus 1 by R2 plus dot till 1 by Rn. So, today let us start with a new concept, that is cells, EMF and internal resistance. After this we will understand the concept of cells in series and parallel, then a rule has to be applied to you, that is known as Kirchhoff's rules, and finally there will be 3 applications of this Kirchhoff's rule, and that will be the end of current electricity. Okay. So, let us start with the new discussion today, that is cells, EMF and internal resistance. So, please look over here carefully. So, on the right hand side to you, there is a complete electrolytic solution which is connected, which is basically used to provide a voltage difference between the two ends of the resistors. So, this electrolytic solution can be compared or can be analogous to this concept here, that is, this electrolytic solution can be used as a cell or battery. Okay, so this is only the explanation here. So, as the points go on, I will try to explain this diagram to you more, and besides this is a formula sheet being updated quite evidently here. So, everything which is important in this lecture or in the complete lecture series of current electricity will be dealt here. Okay. So, look very carefully now. So, a simple device to maintain a steady current in an electric circuit is the electrolytic cell. So, any device which can be used for a constant steady current can be, one of the example is electrolytic cell. Now, what is an electrolytic cell? Basically, a cell has 2 electrodes called the positive and the negative. So, let us suppose this is that positive electrode. Electrode is just a what we can say, it is a single rod which is known as electrode. So, this is electrode, this is a positive, as it is denoted by P, and this is negative, which is denoted by capital N. Okay. So, basically a cell has 2 electrodes called the positive and the negative N. They are immersed in an electrolytic solution, quite evident, as you can see it is immersed in an electrolytic solution. So, this thing is also been explained, everything is just line by line, very easy method it has been explained here. Dipped in the solution, the electrodes exchange charges with the electrolyte, quite evident, there may be charges here and there may be some charges or let us say 0 charge at the initial portion, and then it tries to capture. So, this positive electrode captures positive ions and the negative electrode captures negative ions. Okay, so dipped in the solution, the electrodes exchange charges with the electrolyte. The positive electrode has a potential difference V plus. So, V plus here change that V with a subscript plus. So, plus here denotes that we are talking about the potential difference at the positive electrode. Okay, V plus is positive, quite evident because only the positive charges are being attained there between itself and the electrolytic solution immediately adjacent to it, marked in the figure. So, what is that V potential difference here? Let us suppose I am assuming the potential difference here to be, let us say V of okay, it can be something capital V of X, let us suppose, and let us suppose the potential difference at this portion is nothing but capital V of Y. So, potential difference V of X, V plus is equal to potential difference of X minus potential difference of Y. So, this is the thing which is explained there. Okay, so between itself and the electrolyte solution immediately adjacent to it marked A in the figure. So, this thing has been explained. Similarly, we do the same thing for the negative electrode also. So, similarly the negative electrode develops a negative potential, quite evident, which is denoted by like this, as you can see, minus V minus. So, we are trying to take the value of V minus or V plus as positive only, and we are assuming or we are adding a negative sign by ourselves here. So, that is why it is denoted like this, and this can be denoted like this, quite evident, as the value of negative charges will be present in the negative electrode, therefore the potential is also negative. Okay. Related to the electrolytes adjacent to it marked B in the figure. Similarly, we can just take this as V of x and this is V of y, and therefore we will find that V of x minus V of y is negative V minus. Okay, V minus, so V minus is a subscript there, there is no minus sign there, it is V minus is a subscript there, and similarly V plus is a subscript in this potential difference denotation. Okay. Now, when there is no current, the electrolyte has the same potential throughout, quite evident, because there is no passage of charges from point A to point B, hence it can be assumed that the charges are at rest in the electrolyte solution also. So, when there is no current, the electrolyte has the same potential throughout, so that the potential difference between P and N is nothing but V plus minus this. So, basically when we are trying to find out the potential difference, as the name suggests, its difference is written, that means we need to do subtraction there. So, what is the subtraction we need to do? There is something called as V plus, there is something called as minus V minus. So, subtraction will be nothing but V plus minus V minus. Hence, when we try to find the potential difference, it is nothing but the summation of the potential difference at what we can say electrode means the potential difference between this plus the potential difference between this. So, this is the thing which I need to explain here. Okay. So, this thing is also explained. Now, let us move on. So, finally, what we got is that the potential difference only and only when there is no current is nothing but V plus plus V minus. Now, this difference is called the electromotive force of the cell. So, hence a new concept has been evolved here. This is known as EMF. What is EMF? EMF is nothing but the potential difference addition of V plus V minus is nothing but called as EMF. EMF. People sometimes get confused, as the name of EMF is nothing but electromotive force. Please make sure it is not a force here, it is just the potential difference. I guess if I have started the lectures of electromagnetic induction also, in there also I explained you the concept of EMF, only electromotive force being induced there. There also I explained that EMF can be only understood, or you just understand EMF as voltage only, it is not a force. Actually the name force comes into picture, but it is not a force, it is a potential difference only. Okay. So, this potential difference is called the electromotive force of the cell and is denoted by epsilon. So, epsilon is being used for the denotation of EMF. So, you just need to remember this, that what is EMF. I will just write it again here. So, EMF is not a force, it is a voltage difference or voltage, and it is denoted by epsilon. What is epsilon? I will just write epsilon here. Epsilon. Okay. Next is thus epsilon is nothing but V plus plus V minus, which is positive, quite evident, as previous also we understood that V plus is positive here, and similarly V minus is also positive here. Therefore, using the addition also we will find that the epsilon value is also positive here. Okay. So, this thing has also been explained. Next, let us move on to this concept here. Note that epsilon is actually a potential difference, not a force. So, only the thing which I explained to you is written here, that epsilon is not a force, it is a potential difference. The name EMF, however, is used because of the historical reasons and was given at a time when the phenomena was not understood properly. So, when initially I won't go into detail of what was happening when the history evolved about the electromotive force, but just to explain to you, at the time when the scientists tried to find out did the experiments regarding this, they found out that the value, it is nothing but a push which is exerted by a charge on itself, so that its movement can constitute an electric current, but that is why, because it was understood as a force, a push, that is why it was denoted some sort of electromotive force. But finally, when the more research was being done, more analysis was being done, it was found out that it is nothing, it is not a force, it is a potential difference, but the name had been changed, it was being kept as electromotive force only. Okay. Next, to understand the significance of epsilon, consider resistor R connected across a cell, quite evident. So, this is, let us say this is the cell endpoints, we are connecting a resistor R. Okay, so this thing is also been done. A current I flows across R from C to D, quite evident, as the charges flow from positive electrode to negative electrode. Therefore, this can be assumed as the direction of electric current. Okay. Next, as explained before, a steady current is maintained because current flows from N to P through the electrolyte. So, a steady current can be obtained as that is the main agenda of using an electrolytic cell here. So, as explained before, a steady current is maintained because current flows from N to P through the electrolyte. So, what is N to P? N is this, P is this, and through the electrolyte the direction of movement is like this, quite evident. Clearly, across the electrolyte the same current flows through the electrolyte from N to P, whereas through R it flows from P to N. So, just please try to understand the direction here. For the resistor, direction is like this. For the resistor the direction is like this, or it can be said as clockwise. Similarly, for the what we can say here, from N to P the direction is in anti-clockwise sense, that is from P to N. As you can see, it is from N to P in this direction, but through resistor R it is from P to N. Therefore, the electrolyte through which a current flows has a finite resistance called as internal resistance. So, this is a new concept now, that so now we are understanding another concept what is called as internal resistance. So, internal resistance is nothing but there is something called as external resistance which we try to put in a complete closed circuit. Similarly, there is something called as internal resistance. What is internal resistance? Internal resistance is nothing but the leakages or the inefficiency of a ideal device to not completely pass the electric current from point A to point B. There has to be a dissipation of energy. That dissipation of energy, if found, is nothing but due to an internal resistance which the device itself occurs into it. Because of this, what happens is there may be an addition in the energy dissipation, and that can lead to disastrous results sometimes. So, we need to find out, or we need to also take into consideration that internal resistance also. Generally, the value of internal resistance is much smaller than the external resistance, but then also if let us suppose our resistor value is very small, then the complete use or the complete influence of internal resistance can come into picture in that sense. If resistors have, let us say 10 to the power 4 ohms and so on, and the internal resistance let us say 2 ohms or 5 ohms, then that does not make any good picture here. But if the resistors are, let us suppose, of only 10 ohms and internal resistance let us say 5 ohms, then the amount of energy dissipated can influence the complete circuit more. Okay. So, the electrolyte through which a current flows has a finite resistance small r called the internal resistance. Consider first the situation where capital R is infinite, so that I is equal to V by R is equal to 0. So, what is happening here? So, at the time, let us suppose we are finding out the current through that resistor R, we can find as the resistance value is very high, therefore, there will be no use of electric current through that portion here. So, we can directly assume the value of capital R to be understood there. Just to explain it again, so let us suppose there is a resistor R in series only, so we can write it as capital V upon R plus R. Now, it is being assumed capital R is infinite. If it is infinite, that means capital R plus small r can be approximated to capital R only. Therefore, we will find the value of capital V by R plus R is equal to capital V by R only. Okay. To consider for the situation R is infinite, and also here as R is very much high, so we can assume the value of current to be 0 or approximately 0. Okay, where V is the potential difference between P and N. Now, potential difference between P and A, so as you can see, potential difference between P and A, that is denoted by V plus potential difference between A and B. A and B is nothing but this potential difference, plus potential difference between B and N, this will be this, is equal to epsilon. So, in this case now the potential difference completely, that is V, is equal to what is P and N? P and N is basically this portion here, but this will be equal to nothing but potential difference between P and A, that is this, plus A and B, that is this, and B and N, that is this, which is equal to epsilon. So, this is just the initial part of how this complete concept has to be dealt with. I will stop the lecture here only. In this lecture, we understood a new concept called as internal resistance and electromotive force. Please make sure electromotive force is nothing but the voltage difference only, and internal resistance is nothing but the resistance which the device offers, because it is not ideal. So, let me stop it here only. I will start from this discussion only in the next class, and then that will be the end of your cells EMF internal resistance also. I guess I will try to explain this complete concept using some of the examples also. After that examples are dealt with, we will move on with the next concept. So, let me stop it here.